There's a takeoff of the industry slogan, "Beef, it's what's for dinner." Beef, it's what's rotting in your colon. I saw this on a shirt once with some friends, and I was such the party pooper, no pun intended, explaining to everyone how meat is fully digested in the small intestine and never makes it down into the colon. No fun hanging out with biology geeks. But I was wrong. It's been estimated that with a typical Western diet, up to 12 grams of protein per day can escape digestion, and when it reaches the colon, it can be turned into toxic substances like ammonia. This degradation of undigested protein in the colon is called putrefaction, so a little meat can actually end up putrefying in our colon. The problem is that some of the byproducts of this putrefaction can be toxic. It's generally accepted that carbohydrate fermentation, the fiber and resistant starches that reach our colon, results in beneficial effects for the host because of the generation of short-chain fatty acids like butyrate, whereas protein fermentation is considered detrimental for us. Protein fermentation mainly occurs in the lower end of the colon, where carbohydrates get depleted, and results in the production of potentially toxic metabolites. Perhaps that's why we see more colorectal cancer and ulcerative colitis lower down, because that's where the protein is putrefying. The most simple strategy to reduce the degree of potentially harmful compounds by protein fermentation is probably a reduction in dietary protein intake. But the accumulation of these harmful byproducts of protein metabolism may be attenuated by the fermentation of undigested plant matter. This study showed that if you give people foods containing resistant starch, that means starch resistant to small intestine digestion, so it can feed our good bacteria down our colon, foods such as cooked beans, peas, lentils, raw oatmeal, cold pasta, you can block the accumulation of these potentially harmful byproducts of protein metabolism. The more starch ending up in the stool, the less ammonia, for example. But there's protein in plants too. The difference is that animal proteins tend to have more sulfur-containing amino acids, like methionine, that can be turned into hydrogen sulfide in our colon, the rotten egg gas that may play a role in the development of inflammatory bowel diseases like ulcerative colitis, as I've covered previously. The toxic effects of hydrogen sulfide appear to be mediated through blocking the ability of our colon cells to utilize butyrate, which is what our good bacteria make from the fiber we eat. So it's like this constant battle in our colon between the bad metabolites of protein, hydrogen sulfide, and the good metabolites of carbohydrates, butyrate. Using human colon samples, they were able to show the adverse effects of sulfide could be reversed by butyrate, so we can either cut down on meat, eat more plants, or both. But there's two ways hydrogen sulfide can be produced. Though it's mainly present in our large intestine as a result of the breakdown of these sulfur-containing proteins, rotten egg gas can also be generated from inorganic sulfur preservatives like sulfites and sulfur dioxide. Sulfur dioxide is used as a preservative in dried fruit, and sulfites are added to wine. We can avoid sulfur additives by reading labels or by just choosing organic, since by law they're forbidden from organic fruits and beverages. Now, cabbage family vegetables naturally have some sulfur compounds, but thankfully, after following more than 100,000 women for over 25 years, cruciferous vegetables were not associated with elevated colitis risk. But because of the animal protein in preservative-laden processed foods, the standard American diet may have 5 or 6 times more sulfur than a diet centered around unprocessed plant foods, which may help explain the rarity of inflammatory bowel disease among those eating traditional, whole-food, plant-based diets.